All right, so this video is going to go over pages 8 and 9 in your sound packet, or sound part 2. Okay, so we're going to learn how to calculate the speed of sound at certain temperatures. So I know we've been telling you in the last unit it's about 340. Okay, that was just generally, we didn't want to get too deep into that. Okay, but now we're going to talk about how to calculate the speed of sound at certain temperatures. So I'm not going to worry about these first couple paragraphs. I'm going to go straight to, this is the equation we give you on how to calculate the velocity of sound at a certain temperature. So you got 331.5, which is a constant. That'll never change. You're not going to touch it. Plus 0.6, don't ever touch that. And all you got to do is basically plug in your temperature right here. So our first example, 20 degrees Celsius. I want to know what is the speed of sound at 20 degrees Celsius. So V equals 331.5 plus 0.6 times 20. That's where you add that 20. And you get a speed of sound of 343.5 meters per second. So at 20 degrees, that is the specific speed of sound. So let's try a couple. So now let's try -5 degrees. So V equals 331.5 plus our 0.6 times -5. Don't forget the negatives. Okay, and you should get 328.5 meters per second. Okay. Now, if you notice, there's a difference between 20 degrees Celsius. 20 was at 343, and now at -5, you got 328.5. So naturally, as temperature goes down, speed of sound will also decrease. Okay, so let's try 40 degrees. So V equals 331.5. So if you notice, I'm not changing any of the equation. So 331.5 is the same, 0.6 is the same, and now you just plug in your 40. And now you get 355.5 meters per second. So naturally, as temperature goes up, speed of sound is going to increase. Okay, so the reason why is, think about sound is basically, it's the transfer of energy from one particle to the next. So think of it like a relay race. Okay, if it's cold, okay, things aren't moving as fast, so it's very hard to transfer that energy to something that's not already moving fast. Versus if it's hotter, those particles are already moving. Okay, so you just gotta hand that energy off and it's ready to go. Okay, so if our temp goes up, what happens is the kinetic energy of our molecules goes up. That just means they're moving a lot faster, which means they can transfer energy a lot quicker. So that means naturally the velocity of sound is going to go up as well. Okay, so let's do some more practice. Okay, so for this, we're going to need a few equations. So we've been dealing with, T equals 1 over F. Okay, F equals 1 over T. Okay, we have our wave equations, V equals frequency times wavelength. Okay, we have V equals wavelength over period. Okay, we also have our new one we just did, V equals 331.5 plus 0.6 times whatever your temperature is. Okay, so number one, it says the period of a sound wave is 0.0059 seconds, so that's your big T. The temperature in the air in which the sound wave is moving is 15 degrees Celsius, so there's our temperature. So what is the frequency of the wave? So if I have T, big T, that's pretty much it. That's all I got. The only equation I can use is F equals 1 over T. Okay, so don't make this more complicated than it is. So 1 divided by 0.0059. So type that in our calculator, and we should get 169.5 hertz. So now we know our frequency. What's the speed of sound at 15 degrees Celsius? So V equals 331.5 plus 0.6 times 15. Okay, and that's going to give us a speed of sound of 340.5 meters per second. Okay, the whole goal of A and B is to get you to C. Okay, so if I want to know the wavelength of a sound wave, I couldn't have found it without finding what I've already gotten A and B. Okay, so there's two ways you can do this. You can do V equals frequency times wavelength, or you could do V equals wavelength over T. Doesn't matter to me. Okay, so whichever way, you should get the exact same answer. I'm going to use the first one. So my velocity is 340.5 equals frequency times wavelength. My frequency is 169.5. Okay, and my wavelength, I don't know. So I'm going to divide both sides by 169.5, and I'm going to get a wavelength of 2.01 meters. So there's your answer there. Number two, we're going to practice it again. So the period of a sound wave is 0.00195 seconds. So there's your big T. I gave you a temperature of 20 degrees Celsius. Okay, so what's the frequency? F equals 1 over T. So 1 divided by 0.00195, and I get 512.82 hertz. Okay, B, what's the speed of sound at 20 degrees Celsius? So V equals 331.5 plus 0.6 times my temperature, which is 20. And we're going to get 343.5 meters per second. Oops, my bad. So 343.5 meters per second. Okay, C, what is the wavelength? So again, whichever way you want to, I'm going to do V equals wavelength times frequency. So V is 343.5 equals frequency, which is 512.82. And wavelength, we don't know. We'll leave it as that. So divide both sides by 512.82, and you get a wavelength of 0.67 meters. Okay, so the whole goal is to show you the steps there. Now, on a quiz or test, I may not put it as A, B, C. Okay, I may give you this problem, okay, give you the whole problem, and then I may go straight to C and say, what is the wavelength of sound wave? So you'd have to know, well, in order to find that, I probably need to look at my equations that have wavelength in it, and do I have enough to get there? Okay, do I have frequency? Nope, so I can probably find it. Do I have velocity, and they gave me a temperature? Nope, so I should probably find that. So again, be real careful with this because it may not just be step by step. More than likely it won't be. Okay, so make sure you can read a problem like this and you can go straight to step C by knowing how to do A and B. Okay, so and that will end that one.